This week, the Nobel Prize in Physics has been announced, and I am super happy. So this week, we are going to be talking about that. This is Monterey. Welcome to your cosmic kingdom. So here you have them, Weiss, Varys and Thorne. These three people helped designing the LIGO experiment. The LIGO experiment, we have done I think a few episodes about the gravitational wave detections and how they do it, but today I'm going to just summarize it a little bit. So the LIGO experiment is an interferometer. What is that? An interferometer, as you can see here, it's a set of mirrors and rays of lights that bounce on the mirrors and come back, so you can create interference patterns. And what they did is create the biggest, largest interferometer in the world, like kilometers or miles long. And they were not only happy to create one, but they created two, so that they have detections of the signal at different positions on the Earth. And now you're thinking, you're telling me like, and why is this important? What exactly is a gravitational wave? Well, we all know what is a wave. We go to the sea, we see the waves, and we see something that is transmitting energy on a medium. Okay, the sound is a wave, the light is a wave. You can think of a wave in the sea. So you have energy that is approaching, that is traveling through the water and approaching to the beach. Okay? And that is energy. Most of the particles of the water just move up and down. They don't change positions, but you can see the wave moving in the water. Instead of water, the gravitational wave behaves more like the same, but instead of water, what they use is the space-time. The space-time is what it is been expanding since the beginning of time, and we believe it's almost flat, kind of, but it can be curved. It can be twisted, it can be warped, and these waves are just that, energy in the space-time that allow it to be twisted and warped, and then also travel on the space-time. So by having an interferometer, which normally are like L-shape, what you can see, if a wave travels through it, they may be twisting this arm in a different way than this arm here. And what happens is you are able to measure the difference, and you can say, oh, there is a wave happening here. And obviously it's much more complicated, because they have to discriminate between seismic waves and a lot of things that can perturbate the system. But once you have everything set up, and these three fantastic guys were leading the team, they were able to discriminate it. And then you see the difference in the way the light propagates here and the way the light propagates there. And they say, you have a wave. But they didn't stop there. Once they have a wave, they need to know what it is being caused. So they have this multiple set of possible scenarios that will create gravitational waves. And what they do is just go using computers to go through them and just try to match the most likely possible cause for that gravitational wave. And in the initial one were two black holes. The theory for gravitational waves have been there for 100 years. 100 years of a theory that has never been proven. These people went to the administrations, asked for a lot of money for building these massive instruments, probably the most sensitive instruments the humankind has ever built, and tried to convince the politicians to give money to put into something that they didn't know they were going to find. And eventually they found it. And it's just opening a new window to the universe, opening a new way of exploring the universe. For instance, gravitational waves are not affected by dust, but they can be affected by matter. And the cool thing is be able to use gravitational waves to detect sources of dark matter. And of course, what are black holes? Black holes are just the corpses of the stars, or the dead bodies of the most massive stars, at least most of them. And with this, we can explore the cemetery of the universe. and by exploring this cemetery, you can extract data about how these stars were formed and how they evolved, will they merge. It's just one black hole, or they will eventually be merging, which was what they actually found on the first LIGO discovery. And if they merge, what is the frequency of these mergers, and how this affects to the youngest population of stars. So there is a new field open in front of us, and I'm just quoting a few things that come to my mind, but I'm sure that they will discover things that are today unthinkable of. So for this thing, Cosmic Kingdom is super happy, and we want to congratulate them. And that's all for today. I hope you enjoyed this episode. See you guys next week. Bye bye. But there are different kind of ways. Sounds, for instance, are material. Wait a second.